All right, we're going to do a little bit of a different introduction to double angle identities. We had these two formulas here that the sine of two angles added up was equal to the sine of alpha and beta is sine alpha cos beta and cos alpha sine beta. The cosine of two angles is cosine alpha plus beta is cos alpha cos beta minus sine alpha sine beta. Well, if we replace beta with alpha, so we've got actually two alphas here, well, what we end up with is sine alpha cos alpha and cos alpha sine alpha. I just put alpha into this formula instead of beta, and I've got one sine cosine alpha. By the commutative principle, cosine sine is the same thing. I've got two sine alpha cos alpha. Now, this is called a double angle identity, and it's real important. Whenever I see the sine of 2 alpha, I could replace it with 2 sine alpha cos alpha, or vice versa. If I see this, I can put this. Using the same technique, the cosine of alpha plus alpha, instead of beta, I put in an alpha. I get cos alpha minus sine alpha sine alpha. That's cos squared minus sine squared. Now, in your formula sheet, you're given these things. So sine of 2 alpha equals 2 sine alpha cos alpha. You're given that. You're given that cos squared alpha minus sine squared alpha is equal to cosine 2 alpha. But from grade 11 trigonometry, we knew that cos squared is really 1 minus sine squared. And if you rub that out and put in 1 minus sine squared, you'll get 1 minus 2 sine squared. And if you rub out the sine squared and put in 1 minus cos squared, you're going to minus cos squared, and it'll give you 2 cos squared. You can do those derivations a little bit carefully yourself. And all of this substituting sine squared and cos squared actually comes from the idea that sine squared plus cos squared equals 1, and just playing around with that. So you should do that carefully yourself and convince yourself that this is true. These three things are true. These three identities we use all the time. And now we're just going to do some questions right here. If I see something like this, 2 sine angle 30 cos 30, I go, wow, that's that structure, 2 sine alpha cos alpha. I can use that right there. And it must equal, this must just equal 2 sine 30 cos 30 must just equal the sine of 2 times that angle, which is the sine of 60. And if I had a special triangle, I could see that that's root 3 over 2. What about 1 minus 2 sine squared theta? Well, I look at the formula that looks up. Well, there it is. 1 minus 2 sine squared theta is really the cosine of twice this angle. So that's why it's the cosine of 60, which is from our special triangles, is just a half. Well, we can do a number like this. Let's take a look at the next one. We'll get rid of those little boxes. Okay, what if you have 2 times the sine of 150 times the sine of 300? Well, the sine of 300, you need to change that. It's really the sine of 60, and sine is negative down there. So it's really the minus of the sine of 60. But I'm thinking, gee, if this was 2 sine cosine, that'd be really nice. So I use a cofunction. Hey, the sine of 60 is really the cos of 30. Well, now I take this negative, put it in the front. Now I've got this sine 30 cos 30, just like up here. It must really be equal to minus the sine of, oh, and as you can see here, maybe I can see that I've made a little mistake. This is true right to here. But now it's exactly like this up here. So this just turns into negative the sine of 60 degrees. Sine 30 cos 30 is negative the sine of 60 degrees. Using that same thing, just looking at this thing, if I have 30 and 30, it gets doubled and turns into 2 times 30. So that's the negative of the sine. But let's look at the last one. Hey, this one, 4 minus 8 sine squared 15 over 4. If I factor 4 out, if I factor 4 out of there, I'm going to have 4 times 1 minus 2 sine squared 15. And I'm going to have a 4 on the bottom. Ooh, that's going to be nice because the 4s will cancel. Now 1 minus sine squared, 2 sine squared, 15, that just doubles up and becomes cosine. It's the cosine of twice that angle right there. So it's the cosine of 30 degrees, which is really root 3 over 2. Okay, well, maybe I did that a little fast, but I'm just using those formulas. You have to look at it really closely yourself. These are 4 questions from the textbook. We're just applying double angle identities, and hopefully that helps you. You can play the video again and sort of slow it down, and things will work out, I hope. Okay.